Let us continue our event with our next speaker, Mohammed Sahar. Please welcome him on stage.
Good evening, ladies and gentlemen. I'm here for a very particular reason. I'm here to talk about humanity. I'm going to make you think. You see, that's the thing about us humans. We are curious. And I'm going to display about that curiosity in just one very simple topic, the idea of extraterrestrial life. But first off, let's start with humanity. What is humanity as of today? Well, today we are essentially a fairly young mammal species, but we can go scuba diving, we can build skyscrapers, we can send animals into space, we can create machines that can replace routine tasks. But more or less, we just branched out from some life form 3.5 billion years ago. At one point of your life, you were just a little cell of 0.1 millimeters in diameter in your mother's womb. But today, you consist of 45 trillion cells, each with their own purpose and technocracy. They do everything you can. They perform tasks related to information transmission. They convert nutrients into energy. Everything so you can find your purpose and leave the legacy of having kids. But what is you? Well, you are just you, but there is essentially a molecule inside your body that defines you. We call it DNA, or the deoxyribonucleic acid. It contains your genetic information for the development and function of all living things. That's right, but if you think about it for a second, in almost every single cell in your body, there exists a little bit of stuff from the past 3.5 billion years or so. We are that old. Now, as for the rise of life, we tend to forget where we come from, right? So let's start questioning in saying that where do all these DNA molecules come from? Well, they come from atoms. Everything's made of atoms. In fact, in just your body alone, there's 7 billion, 7 times 10 to the power of 27 atoms in just your body alone. That's a huge number. And out of those, 93% are dominant in carbon, hydrogen, and oxygen. As for the remaining 7%, well, there are a myriad of other chemicals. You have potassium, phosphorus, sulfur, molybdenum, arsenic. That's even right to even have toxic materials in your body, but you're still alive. And that's the greatness about us, about our body. We're able to do so much. Take lead, for example. But where did these atoms come from? Well, a little bit after the beginning of the universe, after the Big Bang. After the Big Bang, only hydrogen and helium atoms existed. Over time, gas clouds grew, denser and denser as more hydrogen and helium atoms mixed. And in the end, they just collapsed under their own gravity, only to form the first stars. And in the cores of these stars, hydrogen was converted to helium through a process called nuclear fusion. And, well, here's the beauty of it, is that after they started running out of fuel, they started going smaller until they cracked onto their own density, and they exploded in beautiful supernovae, such as this beautiful crab nova you're about to see, right? Crab nebula you're about to see over here. The universe is beautiful. We find such amazing things, and then we realize that it's all happened a long time ago, but it relates to us, and that's why we are related directly to the beginning of the universe. You see, we too are made of atoms. We too share a connection with the very first stars. Because why? Earth was once dust floating around in space until gravity came, and because of the sun, gravity came and compacted them into one solid body. And then, magically, with a bit of sugar and spice, life as we know it grew. So, since we share a connection, since we are made of these little things that everything in the universe is made of, and that the very same process of star formation, of planet formation, may have happened in billions of other regions in space, wouldn't it be only fair to consider that perhaps this life formation may have also happened in other areas in space. Perhaps we are not alone. Ladies and gentlemen, I promised you a mystery, and that's what we're going to talk about today. The region we live in space is quite ordinary. We have 8 planets, all of which orbit the sun. And for every grain of sand on Earth, there are 10,000 stars in the night sky. Overall, there's 10 to the 22 to 10 to the 24 stars in the observable universe. Now, that's still a pretty big number. Obviously, not everything can contain life, not every single, planet that surrounds a star. That's why we have, we can actually cut down this number a little bit. So roughly 5% of those stars have planets to start with. So that leaves us with 500 billion. If you consider the whole number, just do 0.05 times 10 to the power of, anyhow, sorry, my bad. And yeah, we have a very basic universe. And when we cut down this number of stars, we're left with 500 billion stars. But there's something called the Goldilocks zone that allows life to thrive in a particular area. For example, that's us, Earth, and that is our Goldilocks zone. The Goldilocks zone is an area surrounding the sun that allows liquid water to exist, and supposedly life. And that's about 1/5 of the total number of stars do have a planet in the Goldilocks zone. Now, that leaves us with 100 billion, 1/5 of 500 billion. So now there are 100 billion stars in the entire universe, 100 billion planets in the entire universe, which may just contain life. And that's over. Remember, I said at least 1 star. Now, in the Milky Way alone, there are 100 billion stars. Now, if you take a relative approximation, that would mean every single grain of sand on Earth represents a planet with the possibility of containing life. So, where is everybody? Why isn't our galaxy teeming with spaceships and intergalactic trade? Why aren't there no fast food restaurants in space? This sort of hypothesis is known as the Fermi Paradox. If there are so many star systems and planets out there, then where are they? Why isn't our space full of people, of species? We even have a whole organization dedicated just to this purpose, SETI. And they really do try their best. And the best example is their leader, the organizer, the founder, Frank Drake, was a person who strongly believed that aliens did exist, that we were not alone, and that there was a way to get a quantifiable answer to our question, to our big mystery of, is life possible? That's Frank Drake. And that's his famous Drake equation. It breaks down the fundamental steps for a civilization to thrive on a galactic scale. Now, it may look intimidating at a first glance, but let's break it down a bit. It's not all too hard. N represents the number of civilizations in our galaxy that we may be able to contact. This is actually the value we're looking for. Our star is the average rate of star formation in our galaxy. Now, we aren't entirely sure as for the number of stars, but we are pretty certain of the number of solar masses, the mass relative to our sun, in terms of our sun. It's about 3. And this one is pretty certain. You'll notice a recurring trend as I go through the variables. F of P represents the amount of stars that have planets. Just planets, at least 1. And we aren't entirely sure of the exact number or the exact fraction of these stars, but it's about 10% to 50%. Again, not very precise, but it's a start. N of E is the amount, these planets which can possibly support life per star. As I said earlier, about 1/5 of these stars do have planets, at least 1 planet, that may contain life. So this one is pretty certain too. However, F of L is where things start to get a bit bizarre. F of L represents the number of planets that may go on to develop life at some point. You see, there's something I really do believe about life, is that the biggest misconception is that life needs water, life needs oxygen, warmth. What if these other species may not need these conditions? They don't have to be like us. They don't have to be like humans. I mean, it's only fair to assume that if there are an indefinite amount of conditions that each planet can have, it's only fair to assume that there could also be an indefinite number of circumstances where life can be present. F of I represents the number of planets with life, but can go on to form a civilization, or simply be intelligent. Now, there is no proper evidence of this. I mean, the best we have is us. But sometimes I do wonder if we live in such an average solar system, in such an average sun, I mean, we have such an average sun, we live on average planets, then what would make us so special to be the only life that we can detect in the universe? F of C represents the fraction of the civilizations that we are able to contact. They have developed technology that can be used to detect their existence in space. The best example, and the only example, is us, once again, and our usage of radio waves. Now, we have been only transmitting radio waves for about 100 years or so, which is absolutely a blink of an eye in the geological scale, or in our timeline rather, 0.0001, if I'm correct. But yeah, it's a very small number. And consider radio waves as the mere inception of our means of transmission. And what if we're just behind? I mean, it's like, and that may be the case with these other species. It's like trying to use messengers or carrier pigeons in an age where these civilizations are using email. We're simply outdated, and it's unreasonable to use. And we're just behind. So it's either that, or we are just, well, the pioneers. But if a civilization did detect us, are they really observing us? It is possible, by the way, that they're observing us right now, this very convention. L represents the amount of time a civilization is able to transmit these signals for, or more simply, how long a civilization lasts. The longer L is, the more technologically advanced a civilization would be. We would actually use something called the Kardashev scale to measure the technological domination of a civilization. It's a hypothetical equation by Carl Sagan, and P, represents the power a civilization uses, and it's split into a couple of categories. I'll just explain a little bit of it. Type 1 on the Kardashev scale, K is equal to 1, would represent a civilization that is able to efficiently use all the power that it can receive from its host star, and as well as its planet's resources. And we sort of lie right below that. And type 2, a civilization, would require a civilization to utilize an entire or almost the entire or almost power output of its host star. This would be like trying to use a Dyson sphere, this little structure over here, that surrounds the sun, that surrounds the star. Type 3, and you guessed it probably, it's numerical, would be a type 2 civilization on a galactic scale. Or it just can manipulate the power output of an entire galaxy. It's a bit sad because we humans aren't even on the Kardashev scale. We are actually at 0.73. It's a bit of a shame that Kardashev would invent an equation that doesn't even include us. Nevertheless, we haven't even detected any one of these civilizations. And that's a bit odd because the universe has been around for 13.8 billion years, and Earth has hardly been for a third of that. So there's at least 6 billion years prior to Earth's existence where civilizations could have thrived and could have fallen. You see, we humans have faced many natural catastrophes, asteroids, ice ages, but we have to consider ourselves and what we are inventing. The past few decades have shown us that we are capable of destroying ourselves, and that's of an even more immediate threat than all these natural catastrophes, asteroids, as I said. But these civilizations out there, what if they're watching us right now? And if we do make contact with these civilizations, it would probably be the most dangerous we have ever faced. I mean, what if a civilization has been detected by us? Should we let them know that we exist? My curious My curious sense in my head says, yes, it'd be amazing, it'd be historical. But the more cautious part says, no, hell no. I mean, think about it. When you are observing something potentially more powerful than you are, you have to be careful. Type 3 civilizations might be doing just that. We're just a lab rat in their overall experiments. And once we start passing a certain threshold of intelligence, they'll just cut us down. After all, we're just one of their science experiments. And essentially, the rat is dead. Now, take a look at AI, for example. AI can help us colonize the galaxy, but it can very well cause our self-destruction if we are not careful. But likewise, these type 3 civilizations might be perceiving us as an AI, but simply we could hit the off button, you could say, right, AI, controllable, and we humans made it. What if type 3 are doing that exact same thing? And essentially, the rat is dead. Why? Because of our own misconception of the beauty of discovering extraterrestrial life. What if it is not what we considered it was? And I just want you to think about it. Have a good thought. But as I said before, we humans have only been here for so long. We've actually been around for 75,000 years. And what if alien life came before life's existence or our existence? Maybe Earth is just not a suitable place. It's like you're a girl and you want to go to a fashion store, but you want to go to the best one. And Earth represents not the best one, more or less, and they just avoided it. It's like how we try, or we don't try, to colonize Antarctica. It's simply unreasonable. The Fermi Paradox is essentially just a mere ideal representation of an educated guess to help with the overall idea of the future discovery of aliens. If just one of those values I talked about were 0, the product would be 0 as well, and we would be the only species out there. There have been answers in the millions and answers of null. It all depends on how pessimistic or optimistic you are and whatever helps you sleep at night. But both answers hold value, because after all, it's all hypothetical. Enrico Fermi may have asked one of the most important questions to do with humanity, but at the same time, he was a pioneer in nuclear weaponry. And once again, we have to remind ourselves that we are capable of destroying ourselves more than we can help ourselves. And we have to be careful with what we have. We have been searching for unusual signs of life in other planets, city lights, molecules essential to life, infrastructure. In 1974, Frank Drake himself sent a message on a search of life to the M13 star cluster. And we have sent satellites, the Voyager spacecraft, that contain plaques that indicate what we are and where we are. We are doing all we can to find life while giving them all they need to find us. We are so single-minded in searching for life that we are forgoing the possible ramifications if we are in fact not alone. Carl Sagan once said that somewhere, something incredible is just waiting to be known. Are we done for, or are we just getting started? Even better said, are we closer to the beginning of humanity or closer to the end? Anyhow, time is only running, and we've only got so much here on Earth. There's only one way to go. You see, just think for a second. I just want you to think for 1 good minute, or a few seconds, just of how far we've come, and how far we can go, and how that can all be, in a snap, be gone, simply because of our expectations. But at the same time, we could also thrive. And that, ladies and gentlemen, is why I made you think today, and why you should think that extraterrestrial life is not what we may perceive it to be. Thank you so much, ladies and gentlemen. Have a good show.